All right, that was Simon and Garfunkel. That song is going to come up at the end in a little video at the end as well. Welcome to the last section of chapter one. Congratulations for making it this far. I'm confident you can finish this first chapter off strong. Hopefully you're ahead. If not, wouldn't kill you to get ahead. All right, quarter one's a great time to get ahead. All right, so 1-4, we're going to talk about representing functions as graphs. All right. A lot of this stuff is stuff that you probably already know or you should know, but that we cover anyway because we've discovered, guess what? A lot of you guys don't know it. All right. So the first thing we're going to talk about here is we have three different types of things here. We have a table, we have ordered pairs, and we have graphs. And we can represent all these things. They're all the same. All right. They're just three different ways to represent them. In a table, we have our inputs. Those are our x's. We have our outputs. We also know those are y. All right. When we have an ordered pair, so this is the point 3,6. So that's my x and my y. If I was going to plot that, remember this is my x-axis, my horizontal axis. I go over 3 on my horizontal, and I go up 6 on my vertical, my y-axis, and I put a dot right there. Same thing for this next point. It would be 1, 4. Go over 1, up 4. Over 5, up 8, just like that. So now you can see these are all the exact same thing. I have an input of 1, an output of 4. That puts a dot right here. Input of 3, output of 6. Input of 5, output of 8. All right? All three of these things are exactly the same thing. They talk about it, just look a little bit differently. So we're going to graph the function y equals 1/4 x with the domain 0, 4, 8, and 12. Now I think the easiest way to start this is make a table. 0, 4, 8, 12. I need to plug these in to 1/4 x. So I need to do 1/4 of 0 is my first one. 1/4 times 0 is 0. Then I can plot that point, 0, 0. Well, 0, 0 is right here. I need to do the next one. 1/4 times 4. 1/4 of 4 is 1. So I'm going to go over 4, up 1. Now I'm going to do 1/4 of 8. 1/4 of 8 is 2. So I go over 8 and I go up 2. And last but not least, I do 1/4 of 12. Go over 12. 1/4 of 12 is 3. Go over 12, up 3. And now I have it. So y equals 1/4 x is this graph right here. All right, the table below shows the average score, M, on the mathematics section of the Terra Nova for BRK, Baumholder, Ramstein, and Kaiserslautern from 2006 to 2011, and it's as a function of time, t in years since 2006. So if we were looking at this, which would be the input, the years or the score? Which goes in? The years. That's our input. Which is our output? The score, y. Now, as you notice, these are really big numbers, right? Really big numbers. I don't like really big numbers. Okay? If I went up to 82, all my numbers would be up here. So I'm going to do this little fancy trick where I make this squiggly line in the first. That tells me there's a break right there. All right? And now I'm going to come up with a graph. So let's see. I have from 68 to 82. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 lines. All right? Well, 82 minus 68 is, 82 minus 68, what do you got there? That is 14. All right? So I had 15 lines. I can go by ones. So this very first line is going to be 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82. Now I only wrote every other line, but I can still understand that this here is 81. All right? Now going this way, my scale is going to be a little bit different. I only need to get to 5. 0, 1, 2, 3, 4, 5. So I'm going to go by 1. 0, 1, 2, 3, 4, and 5. All right, so now I can plot it. 0, 68. 0, 68 is right here. It's hard to see because of my drawing. 173. 1 is here. 73 is right there. 274. 274. 377. 3 up to 77 is right here. 478. 478 is right there. And last but not least, 582 is right there. Now notice this. This is real data. It doesn't look perfect, does it? There's some gaps there, okay? Make a rule for the function represented by the graph. Identify the domain and range of the function. I'm going to do domain and range first, all right? I'm going to make a little table. I think that's going to help us when we do this. So let's see. This first point is 1 over 1 up. X is 1, Y is 1. This point here is 2 over 1, 2, 3 up. 2 over, 3 up. 2, 3. This point is 3 over, 5 up. 3 over, 5 up. Over here I have 4 over, 7 up. 4 over, 7 up. Not just your favorite soda. 5 over, 9 up. 5 over and 9 up. All right, so let's take a look at this. Now this one might be a little bit tricky, all right? How can I get from 1 to 1? Well, I could add 0. That's not any fun. All right? Because 2 plus 0 is not 3. All right. So let's see. I could multiply by 1. 1 times 1 is 1. 2 times... that's not quite it. All right. Now I'm going to notice something down here. This goes from 1 to 2 to 3 to 4 to 5, right? Down here, this increases by 2 every time. Anybody know what repeated addition is? When I repeatedly add the same number, that's just multiplying. So I'm going to start my trick by multiplying by 2. I'm going to see if that does anything. 2 times 1 is 2. How do I get to 1? I subtract 1. See if it works. 2 times 2 is 4. Subtract 1, I get 3. 2 times 3 is 6. Subtract 1 and 5. 2 times 4 is 8. Subtract 1, I get 7. 2 times 5 is 10. Subtract 1, I get 9. So my rule is 2x minus 1. Here's my range, or my domain. Here's my range. All right, so you try it. Pause the video, try these, and then we'll see if you got them right. All right, so I need to graph this. So I need to get my x's and y's together. All right, I know my domain is 0, 1, 2, 3, 4. If I do this, if I plug this in, 3 times 0 is 0. 0 minus 2 is negative 2. Oh, geez, Sullivan, we don't know that one yet. We'll get to that. Next one, 3 times 1 is 3, minus 2 is 1. 3 times 2 is 6, 6 minus 2 is 4. 3 times 3 is 9, 9 minus 2 is 7. And 3 times 4 is 12, 12 minus 2 is 10. Now, can I plot 0, negative 2? Is there a negative here? No, I'm not going to plot that one. I'm going to go over 1, up 1. Now I'm going to go over 2, up 4. Over 3, up 7. Over 4, up 10. And there's my graph. All right, for the rule, I'm going to first find my table because I think it helps. So my first one is 0, 2. Then I have 1, 2.5. Then I have 2, 3. Then I have 3, 3.5. Then I have 4, 4. And I have 5, 4.5. All right, this one's going to be tricky because of those halves. I think we can do it. Remember that thing I just taught you. Increase here, 0.5, 0.5. What is it called when you repeatedly add the same number? Multiplication. So I'm going to start by multiplying by 0.5. So y equals 0.5x. So let's see here. Let's try one of these. What's a half of 2? A half of 2 is 1. 1 plus 2 is 3. So I think I'm going to have to add 2. Let's try another one. What's a half of 4? A half of 4 is 2. 2 plus 2 is 4. There is our rule. All right, so that's 1-7. Good luck on the bookwork and the application. Knock out that mastery check and then get done with chapter 1.